Welcome back, everyone. I hope you all enjoyed the first networking break of the day. We're now ready to dive into our second round of presentations, and kicking us off is Ian Clifford speaking on decarbonizing and decentralizing the production of ammonia. Ian has spent his career combining his love for environmentalism, technology, and marketing with Fuel Positive as its culmination, where he currently serves as CEO and board chair. Ian is Fuel Positive's key spokesperson for all aspects of the company's outreach to investors, governments, and other stakeholders, and has successfully led the company to global brand recognition. Since 2006, Ian has raised more than 75 million in equity financing for the company. Fuel Positive's mission is to be a leader in fighting climate change by creating and developing practical, clean, and sustainable carbon-free solutions that can be implemented economically now. So, Ian, it is a pleasure to have you with us. Over to you.
Great, thanks for the introduction, Beth, and it's a real pleasure to be here. It's great to talk to an audience who is so centrally focused on what we're doing, and of course the importance to pretty radical change in agriculture in the coming years and decades. So again, nice to be here, and we're very proud to help sponsor the conference as well. So thank you for that. I just want to make sure, can you see my slides when I click over here?
Yes, we can, Ian.
Yes, we can. Okay, great, excellent, good. So again, thank you for the opportunity, and we're really excited to be here. I'm going to start with our disclaimer. We're a public company, so this has to be at the front of every presentation we do to the public. You can read it on your own time, or we're going to use up all 20 minutes. So we're a Canadian-based technology company. Our technology is developed, intellectual property is developed in Canada, and we are commercializing it here, initially for distribution to agricultural operations in Canada, but ultimately for export around the world. And I'll talk about that a little bit further. We invest in technology solutions that we can commercialize immediately. These aren't technologies that have multiple decades in terms of rollout. We know that the issues, the environmental issues and the food imperative issues exist today, and we're focused heavily on technologies that are ready for market now. Our initial technology is a containerized on-farm green ammonia production technology. I'll talk a little bit more again about how that works, but it is truly a revolutionary and transformative technology, given where the world is today, related to the production of food to feed people. Our model is entirely decentralized, and I'll probably spend the most time just talking about this imperative. Supply chains are broken. The access to fertilizers is heavily disrupted today. Costs are out of control. Farmers are in incredibly vulnerable positions as it relates to production and the supply chain. So when we started looking at our technology, we realized that we could actually create some really meaningful resilience for farmers by giving them independence. And our systems are designed to work on farm, to be powered by green electricity on farm, either off a green grid, or in the event that the farmer isn't on a green grid, through solar and wind, geothermal, other forms of renewables, so that the farmers could produce, store, and utilize all of their fertilizer needs. We also have this really interesting opportunity in green ammonia to shift into fossil fuel replacement. So imagine a farmer today who's vulnerable to crazy price fluctuations and lack of supply, both on fertilizers and on fuel, being able to produce their own inputs on farm. And this is for decades. This isn't a year-by-year situation. This is a situation where farmers can lock in that security for decades. And the response we're getting, as you can imagine, on a farmer-by-farmer basis, is pretty extraordinary. Just quickly, this is what it looks like on farm. It's kind of a closed loop system. We've got everything from fertilizer production for various crops, everything from open field crops to controlled environment farming. We can output multiple types of nitrogen-based fertilizers, everything from anhydrous to aqua ammonia, which is of course suitable for fertigation type applications. And we're also doing a lot of work right now on grain drying. So this is, I mentioned, open flame utilization of ammonia as a fossil fuel replacement. So pretty interesting, pretty compelling technology. Multiple uses for green ammonia. I'm not going to go into every one because we'll use up all the time, but suffice to say that green ammonia really shifts the playing field away from incredibly heavily polluting gray ammonia, and producing on site where it's needed changes supply chains. It creates independence for end users, and again can revolutionize how these industries can operate in the future. Here's a shot of our hydrogen component for the system. Our systems are fully containerized, 20-foot container footprints. The idea being here, of course, that we can build all of our systems in Canada and export them around the world. It's a carbon-free production system, meaning that as long as the input electricity is carbon-free, the output is pure green ammonia. It's not blue ammonia, it's not purple ammonia, it is in fact pure green ammonia on site. And it is disruptive to how ammonia has been produced over the last 100 years. Anyone who's familiar with the industry knows that it's tied at the waist to the oil and gas industry, and has been, of course, for the last century. Gray ammonia production is one of the most carbon intense manufacturing processes on the planet, and 80% of the gray ammonia produced every year is used in agriculture. So this creates a massive carbon footprint for agriculture that most people aren't even aware of. So the idea of decarbonizing that primary input is our core mission. Our specs, it's a 100-ton per year system, one module, and that would produce enough nitrogen fertilizer for about a 2,000-acre farm. It's very low water consumption. The neat thing about doing things in a decentralized fashion is that you don't put a huge demand on local resources that centralized production does. So again, managing the growth of our systems. They're engineered to run for decades. So this is a permanent installation on farm, designed again. The first major interaction with the system would be a catalyst renewal at about the 15-year mark. So the idea here, permanent, very little input from the farmer at all. We've designed these systems to be managed and run remotely, to make things really easy for farmers who already have enough on their plate with climate change and all the other pressures that exist for farmers today, as we all know. It is remotely monitored, so Fuel Positive will manage the operation of the system. There's a lot of built-in intelligence for the system, but we've got the ability to ramp up our production at real time, which means interacting with renewables is perfect for a small-scale system, which allows us that kind of flexibility in terms of operating. And it's an extremely affordable technology based on farm use capital expense today. We're also looking seriously at what happens to our green ammonia once it's produced on farm. Of course, many of you understand that nitrous oxide emissions and nitrogen-related emissions are a huge issue on farms. And we're doing a tremendous amount of study now to help mitigate and minimize and hopefully ultimately eliminate nitrogen-based emissions on farm. So another big part of our mandate as a emissions-free company is to help our end users benefit from the best practices. So we've actually got our first study underway right now with the University of Manitoba. We'll be announcing more on that in the coming days. And this will be located on the first demonstration farm for our systems. We've also got a lot of interest brewing now in controlled environments, which of course have constant fertilizer needs, nitrogen needs specifically. And we can adjust the output of our systems on the aqua ammonia side to vary the concentration of nitrogen. So we can be a very interactive part of the supply chain for controlled environment, and we're on site, meaning that any shortages, any supply chain issues, any cost fluctuations would be mitigated entirely by a fuel positive system in a controlled environment agricultural setting. We've got some great advisors in that space. There's a lot of information of them on our website, but doing some great work with Lenore Newman. We're also looking into cellular agricultural technologies as well as an adjunct to what we're doing. And also working with the University of Guelph on a number of controlled environment studies as well. So that's very, very exciting. So status of where we're at today. Our first system will be farm ready end of the year. The intention being it's going to go on to an 11,000 acre crop-based farm based just outside of Winnipeg, Manitoba. This is actually a shot of one of the fields. This is setting up actually one of the nitrogen study programs, research projects that I mentioned. This farm has been using anhydrous ammonia as a fertilizer since the late 1960s, incredibly familiar with it. But this year, prices were up about 400%. They had an incredibly hard time getting any supply. So this farm is a perfect candidate for our systems. Manitoba grid is entirely green. Energy costs are around 6 cents per kilowatt hour. So they'll be producing their own anhydrous ammonia on farm for now about a little over $500 per ton. Which is considerably less than they're paying for in the market today. So we've been testing all the major components in our system. Everything is performing, in fact, above specification now. So we're very, very excited about how things are working there. All of our equipment is independently validated. And we started pre-sales a couple of months ago, and we've had interest all over the world, which isn't surprising at all for us now, given how broken so many supply chains are on the fertilizer and certainly and additionally on the fuel front. The idea of getting into carbon-free, renewable-driven input production for farming is of tremendous interest. I think farmers are now have reached the point of just being completely fed up with the way things have been happening for the last number of decades, and are really looking for independence, really looking for resilience. And this will build heavily into global food security, we believe, as farmers decentralize production of key inputs and move forward into this new reality related to their fertilizer and fuel input needs. And we're ready to start mass production throughout 2023. We have we'll plan to start building a 150,000 square foot state-of-the-art facility just outside of Toronto during the year, and getting into mass production deliveries probably starting early in 2024. And based on the interest that we're having now and commitments, we think that that's a reasonable objective. I think that's my last slide. Yes, that is my last slide. So I'll end on this one, and really happy to take any questions.
Thank you, Ian. That was wonderful. Yes, we do have a question. And yeah, please keep those questions coming as well into the chat box or the Q&A box. Thank you. So I know you mentioned there on that status slide kind of where you're at the moment. Could you give us a little bit more kind of specific information about the amount of farms that are using your products and which countries you're currently in? And also, what are some of your goals and projections for, your growth in the next kind of few years?
Yeah, no, it's a great question. So the system that we are building now will be the first on-farm system for the company. So we are just at the stage of commercialization. That's, as I mentioned, going in onto an 11,000 acre plant-based farm just outside of Winnipeg, Manitoba. So and we have a tremendous amount of interest across the Canadian prairies, throughout the United States. Interest coming in from Australia, from Africa, from Europe, anywhere where input supply chains have been disrupted dramatically and costs are going through the roof. So our system, solves those problems on ground for end users. In this case, of course, farmers to start with. Our growth plans, the facility that we'll be building over the next year, our output out of that, we're planning probably 1 to 1.5 systems per day. So that gives you a sense of the type of growth we'll be ramping up over the next 18 months. And we expect that we'll have to probably do that continually over the next decade to meet global demand, because the interest in decentralizing and building resilience is growing on a daily basis, and the amount of incoming interest we're getting just based on those facts, features alone is exceptional.
Amazing, congratulations. We've got a question from David, and he says, "Sounds great, Ian. What is the cost difference per unit of nitrogen compared with off-farm sources of traditional urea?"
Yeah, no, so that, again, a great question. We don't produce urea, so I can't do a direct comparison. Urea has a huge carbon dioxide requirement, and we're not a fossil fuel production system. All urea is produced around fossil fuel fired plants that are producing anhydrous ammonia. But I can tell you, comparative to both aqua and anhydrous ammonia, we are incredibly competitive. So I was at a very large potato farm in Manitoba a couple of days ago, and they utilize about 900 metric tons of ammonia-based fertilizer per year. This past year, they were paying around $1,500 a ton delivered to the farm. They have 4 cents per kilowatt hour green electricity on farm, including over a megawatt of solar. And they would be producing a ton of ammonia out of our system for about $300. So that's the delta. It's massive, and it's locked in for the most part. They could then they could rely on supply and cost stability for the coming decades. And this is where this becomes truly revolutionary, is you're taking this global commodity in gray ammonia, and you're turning it on its head. You're basically saying, no, this is no longer a commodity. This is now an input for my farm that I'm producing on my farm, and I have no need for any third-party involvement in that most significant input in my operation. So you can imagine how excited farmers are getting with this concept. So the first system will be on farm early and commissioned early in January, which is great because it's going to be probably around -40 degrees Celsius in Manitoba. It's a good place to start. If it works there, it's going to work anywhere. Let's put it that way. And we've got an amazing manufacturing and engineering team. So the systems they're going to perform, and we're really thrilled by that. And what we're going to be doing for farmers, one farm at a time, but this is going to be exponential.
Yeah.
Because there are a lot of people waiting to kick the proverbial tires of that first system, as you can imagine.
Yeah, absolutely. And we're getting some great questions and comments coming in through the chat. Unfortunately, we are at our time. So if you did have anything else that you wanted to share with Ian, a question or a comment, please do. You can send it to Ian directly through the platform, and I'm sure he would love to receive those. But yeah, lots of excitement going on in there, Ian.
Oh,
Thank
great.
you so much. This was a really wonderful presentation. And yeah, we will see everyone in the next room in a couple of minutes.
Great.
Thank you, everyone.
Thanks, everyone.